Hello and welcome to my first math video. So this is going to be, this is going to be a review of everything from Unit 2. I know the students took the Unit 2 test last Friday when I was out, but everything that we learn in the units follow along with each other. They're traveling units. So they learn a piece here, they learn a piece next unit, and by the time we're done with third grade, they have all these pieces together that when things start making a lot of sense. Please note too that in our first two units, it's a lot of strategies. So I know our first unit talked a lot about estimation and a lot about rounding. And that's just how some people do math. Some people find it easier to round it to the nearest 10 or the nearest 5 instead of coming up, for example, if your cookie dough was $4.95. Some people like to just round that to the even $5 and then just subtract there. So it's just a strategy. If your student likes that strategy, they can go ahead and use it. If it's not for them, as long as they gave it a try, that's all that matters. The second thing that I'm asking for is I need the students to show work. I know some students can do the work in their head, which is fine. I know my brother could when he was little, but it's the only way I know that they're not going home and handing the paper to you or going on the computer and typing in how to do this and writing answers off the internet. I have to know what they're thinking inside their head in order to help them. So if they come home and they get all of them wrong, let them get all the problems wrong because I need to see and have them show work so that way I know where and what they're doing. This will help them in the long run. I know they'll get frustrated because they'll have to do it another day, but I can help them so they won't be as frustrated. And I don't expect them to know everything and be perfect. I expect the students to make mistakes. Some of this stuff is brand new. So please let them try, let them show me their work, let me see what they're doing, and if they get them all wrong, they get them all wrong. I have them redo it, and then they'll get them all right. So first things first, the big thing that we're going to be touching on in Unit 3 and in Unit 2 is place value. So place value, for those of you that may have been a while since you've done place value, let me select a brush. This is the first time I'm using this type of program, so bear with me. So place value again is not the straightest line, but that's okay. So we have your chart, and we're just doing simple ones, which I always do a O, T for tens, hundreds, and thousands. We are just doing basic, so we don't need to go into the 10,000, 100,000. We're just working with these. This is the most simplest form of place value. As I said, when we start getting up into the higher units, we start adding on more place value. But we just want to make sure the students know where the ones are, where the tens are, hundreds and thousands. We also want them to be able to identify where the numbers go in place value. For example, if the number is 20, actually I'll do 30 because my 2's look a little weird on here. So if it's 31, we want the students to know that the 1, the back number, goes in the 1 spot, and the 3, which is in the 10 spot. Now, this 3 does not exactly stand for 3. Since it's in the tens place, it's saying that there's 10 long rods, which if you break those apart, it actually makes it 30. Then you're adding the 1 from the ones place, which represents that you have one little cube. So if you put them together, 30 plus 1 equals 31. That's what the place value is that we're talking about in class. We're also talking a little bit about commutative property, which I'm going to open up a new page. So commutative property is pretty much just what the word commute stands for. You move. We talked to the students about when you commute to work or they commute to school, that they're moving back and forward. So, excuse me. So when we have commutative property, it may be a problem like 4 plus 5 equals. And then on the opposite side of the equal sign, it will say 5 plus blank. And it's supposed to be for them to fill out what goes in the blank. I taught the students that what you do is you take an arrow and draw every number that's on one side of the equal sign see if it made it over to the other side of the equal sign. So this 5, it made it over. It's right here. This plus sign made it over. It's right here. Oh, but the 4 didn't make it over. So it has to be the 4 that's missing. And then you put the 4 there. It's pretty much showing the students that in addition, you can write the problem any way you want. 4 plus 5, it's still going to equal 9. 5 plus 4 is still going to equal 9. And that they have the option to move that around. So that's commutative property. That's a lot of the problems. I know some of them would just have an equal sign, then plus 4, and then some of us thought it's supposed to be 9. But no, it just wants you to commute the numbers over side to side past the equal sign. So that's commutative property. The next thing that we were working on was rounding. And we're just working on the basic rounding of the tens. So on my classroom window, I have a little roller coaster. Everything from 0 to 4, you round down to the nearest 10. Everything from 5 to 9, you round up. So if the number is 34, okay, we look at the back number in the 1 spot since we're rounding for tens, which is going to be the 4. And 4 tells us to round down, which is awesome, but where do we round down to? That's why I think the students are getting confused. You round down to the closest 10. You wouldn't pick 20 because that's too far away. You would pick 30 because it's closer to 34. So what I've been doing for a lot of the students is if they round up, I give them the option. They're going to round up to 40 because that would be the next biggest 10 closest to them. If they round down, they're going to go back to 30 because that's the lowest number to them, lowest 10. We use the one place to tell us how we're going to change this 10, if we're going to make it go up or down, up 1, or if we're going to leave it alone and just put a 0 in the back. So that's just the basic of the rounding is, as I said, anything 0 through 4, you round down, 5 through 9, you round up. And their answer has to be something that you say when you count by a 10. So 34 cannot be 35 unless it wants you to round to the nearest 5. So most of our papers just say round to the nearest 10. So that's what we're working on there. We're also working on a place greater or less than, which greater or less than is, say you have 40 and 30. And they want you to find the biggest number. So I taught the students that the arrows are great if it works for them. I teach my students to use Pac-Man, and I always tell them Pac-Man is a fat man because he likes to eat lots of food. That's why he's so big and yellow. So if we go around the greater than symbol, and I give him a little eyeball because he has to see what he's eating, Pac-Man will always eat the bigger number. Some of my students said alligator. If they know the alligator, that's perfect. I encourage Pac-Man. It's the way I learned it. I like it because I like the video game and it makes me think of video games. So if you want to do Pac-Man, that's perfect and awesome for me. So that's another strategy that we're doing. In Unit 3, I was looking ahead. We are talking about adding and subtracting three-digit numbers. Three-digit numbers, digit stands for numbers. So digit can be 5. 5 is a digit. 6 is a digit. 22 is a digit. It's a double digit. And then we start talking about double digit. Think of baseball. Doubles when they go to second base. So that means 2 numbers. Triple digit is, just like baseball again, when they're on third base. That's 3 digits. So we'll be working with triple digits. The biggest thing for third graders out of all my years teaching this is lining up those numbers. So many students like to write their numbers if the number is 452. They love to write 452 minus 320. They will put the 3 here, the 2 here, and then they go and subtract. And this is just slap mess. It makes life hard for everybody. So that is not a good way to do that. So we spend a lot of time teaching the students how to line up those numbers so that way it's nice and easy. So, if the number was 420, I always tell them to write big. So we're going to write 4. and then do a little bit of a space, not a gigantic space, but a little space. So I'm going to change it to 30 because when I do my 2's on here, they don't look normal. So here's the 30, and then the 1's is the 0. And then if we're subtracting it from 100, I'm not going to do a borrowing one yet. And actually, we'll start with adding first. But as you can see, it makes it a lot more manageable because now everything's lined up. Later, we talk about how to break down the problems. When I was a child and I would have double-digit numbers or triple-digit numbers, looking at all these numbers scared me to death because I can't do that in my head. That's too big for me. And what students don't realize is just break it down. Draw a line, which we're going to call them racetracks. Just break it down by place value. So, and I'm going to change this to addition. So start in the 1's, break it down. Everybody knows what 0 plus 0 is, 0. Go to the 10's. Do some racetracks there. Just simply, when we do racetracks, it's telling the students to ignore everything but only focus on what you're drawing the racetracks for. 3 plus 0, it's 3. And then the hundreds, 4 plus 1, which gives us 5. So that's how I teach the students to set up their problems, to give them a little bit of space. When we go to subtraction and we start to do the regrouping, I start having them add more things like question marks and do all this other stuff. But it helps them because so many students forget to look and see what they need to do. So right now, make sure that when your student does triple digit or double digit problems, have them break it down because so many of them get fearful and it's just simply making it into a smaller, more manageable problem. Let's see. The other thing that we'll be working on, I did hit new, didn't I? Oh, let's say, where did it go? Okay, so the other thing we work on too are these making a picture box. And when I first started teaching a few years ago, I thought, oh, how cute, we're going to draw some pictures. No, it's not that kind of picture. So what it is you get a box that looks like this. And I know I'm an awesome drawer with this website. I'm just a regular Picasso here. Alright, so this is the picture. What this picture means is these two numbers that we put in these boxes are actually going to have an invisible addition sign. See this line that's splitting them up? It's actually an addition sign that we just cannot see. So it means whatever these two numbers are, they have to equal whatever number goes on top of here. So if it's 6 plus 5, that means that my sum up here has to be 11. So pretty much for drawing the pictures for this box, and I'm kind of getting ahead of the lesson, so if you want to start showing your student this, you can. Mr. Murphy and Miss Munson will have to do this too. It means that the two numbers in these two boxes you have to add together to get the sum up here. When it is subtraction, they still the same picture, but the invisible plus sign goes away, and one of the numbers will go away. So then you have to imagine the invisible subtraction sign, which is right here. Here's the invisible subtraction sign. And it's saying 11 minus 6 equals something in here. I tell the students, since subtraction is a little bit harder for some of them, just to do the adding, figure out what plus 6 equals 11. If your student knows how to go ahead and subtract 11 minus 6, let them do it. Whatever they can do the best, let them choose. So that's what I tell students to do, and then of course they know it's 5 that goes in here. So yet again, when you get these fun draw the picture boxes, there's an invisible plus sign here for when the two numbers in here have to equal the sum up here. Sum is the answer to an addition problem. Difference is the answer to a subtraction problem. Excuse me. And if by chance one of the boxes is blank, but there's still a number up here and a number in one of the other boxes, that means we're going to subtract. So this is something we'll do a little bit later on. I'm just giving you a quick sneak peek into it. So looking at Unit 3, we're mostly talking about how to set up a problem correctly. Make sure it's nice and clean, nice and straight, nice and easy. Kind of math is very closely related to science. So think if we had a science experiment. We would want all our chemicals separated until we started putting them into the container, whatever we're using, the beaker, whatever.